Well, gentlemen, this was sent in by Mr. C. This has been here for 18 plus months waiting for me to look at it, by the way. Hello, Luke. I bought this amp. So the fan is not hooked up. Lots of small wires not hooked up. Purple wire on bias circuit not hooked up. No wires hooked up to preamp switch, and looks like relay was changed to a vacuum relay, but they put it on a foot switch. I would like to have it put back to factory, and then can you give me a call? Thank you, Mr. C. Bag of dicks. Let's open it up and see what we find. So there's a dent here in the lid, and this thing weighs a ton, so it tells me it's got a transformer in it, which is not bad. It's actually good. In my opinion, the transformer amplifiers do produce a little bit more power. But from what it sounded like, this thing is a mess on the inside. So I can't wait to get this open and find out what we got going on. Babies!
Hi, love.
What you doing?
Family's home, announcing presents.
Announcing it to everybody in YouTube land. That's what we're doing.
Announcing our presents.
Okay. Hi.
Hi. I'm gonna go start dinner.
Okay.
All right.
Bye.
Love you.
Love you too. So let's find out what we got inside. Oh, it's a 6 Toshiba vacuum relay. Doesn't look as bad as it sounded on the paperwork. Not at all. Fan not being hooked up's a bad thing. It's got breakers instead of a fuse. Let's come on up in here. Let's all go look at this together. Let's see, do we got any burnt tin ohmers? Not that I see. It's got a thermal cutout in it. A cheap foot pedal switch here. I used foam dielectric here. I wonder what they were trying to achieve. It's a 100-volt fan. They got red and black wires, and he's right, it's not hooked up. Foot pedal is on a, it's on a switch. Yeah, they utilize the preamp relay. Wow, why? Somebody must have been using this for a driver. See, black, white, red. It's set up for sideband, but then there's no. Huh. They've cut the preamp completely out, so we got nothing to even work with there. And I don't build preamps because I freaking hate them. Well, the vacuum relay is not a bad thing. It's not. And I think with us adding one relay on the input, this isn't even hooked up. This whole circuit's not even hooked up. Extend these wires out, hook them up over here to the fan. Other than their solid core, and it looks like it's broken off the fan. Yeah, I don't see this being a big deal. Okay. Let me call Mr. C and see what he wants to do. This is an old Carl built box. But this here is not Carl technology, but it's okay. Well, breaker's good. This here though, that could be bad. Called Mr. C, and we've got ourselves a 110 volt single pole vacuum in here. Single pole, single throw. What we need is double pole, double throw. And so they're using this secondary relay over here to switch the input, which is it's questionable. just because of the quantity of power that would need to go through this relay. There's zero capacitance compensation for all of this shit. This should not be laying on top of here. This is your output inductor coil. So our output RF is now crossing over our output inductor coil. This is our input wire. It's a ton of wire. There's no capacitance, there's no compensation for that. Anyhow, this is a 110 volt relay. Okay, so it means we can't switch it with an auto key the way this guy wants to have it set up. And I mean, that's an awesome idea, but we'd have to leave another relay in here, which I could rework this one for the input, then add a second relay to run the bias and to run the other two relays and keying. But we've got to get rid of all this. Is solid wire. This is solid wire. I got to get rid of all this solid core wire that's in here. So this is all got to come out. I got to take all of this, y'all. It's got to come out in the back end. But I think what we're going to go with is a regular 30 amp relay, more than adequate. We're going to put a capacitance tuner in here and get rid of these disc capacitors because they have a tendency to get hot, and it's just a failure point. This is a problem here. It's a really common problem. So we'll get that fixed up. Either that or we'll replace all these little bridges and we'll put a big 200 amp 1600 volt rectifier, single rectifier in there, which I've had a lot of success with. They don't seem to fail. Okay, so first off, we're going to rip the ass end out of this over here. We're going to get rid of all this stuff here in the back, and we'll put it more back to a traditional setup. We're going to get our fan working because I'm kind of interested to see how fast this turns. And yeah, make sure it's pushing air into the cabinet. What in the hell? Just random wires hanging out. Okay, let's quit crying and let's start fixing. That is a shame. It says VHC 1 through 26 volts, 26.5 volts, volt DC. And they had this hooked up to a 110 volt source. Son of a bitch. That sucks. Well, we got the back end of this all cleared out. The vacuum relay was held on with one little tiny spot of solder in it. It was actually ripped. The board, phenolic was ripped up underneath it. So when I removed the vacuum relay, I got the spot, but needless to say, we're going to mount this just like so, and it just fits right into the hole that it's supposed to go into. We will be hooking this leg of the thermal couple up to this leg of the relay. The whole idea behind that thermal switch is that if the amp gets too hot, it shuts the amp off and it protects the transistors and protects the box. A lot of guys I know would lose their ever-loving bacon if they had this. They're all about having control. We're going to leave that in there because it's in there for a reason. Look, y'all, this isn't a 100% duty cycle box. This isn't designed to be turned on and left on. This is something that you use and then give it a minute to cool down. Now, that all being said, this cabinet does not lend itself to the best airflow design. Like we have covered in many YouTube videos, there's a big hole that's back here, right back here, and it leads right out to the vent in the back. So the positive pressure that this fan is applying to the cabinet, pushing air in, has to wrap around all this turd bucket stuff, which is drag, and then find its way down the heatsink and come out the back. Or it simply goes, oh, hey, look, there's an exit here, and goes right out this hole. So we're going to have to block this off. Now, the upside to this is an old school amp, okay? Which means the heatsink runs from this screw to this screw. It's literally this wide. Take my headset off, my phone's ringing. It's literally this wide. There's a lot of metal mass underneath these 6 transistors. And it's got big, big fins underneath it. See the big fins? That means lots of good non-restricted airflow. Okay. So if we block this hole off with a little piece of phenolic, then most of the air is now forced to go down and around and come out. How much velocity we get out of that, we don't know. That wraps back around to this thing. If this thing gets too hot, it simply goes click and shuts off. Doesn't allow this relay to key up anymore. No more transmit. But once the amplifier cools down, enough air moves through it and cools this off, cools the heatsink off, click, it'll re-engage and you can go back to doing your talking. We're going to leave this in. Most guys would lose their if they had this, because it never fails. You be right in the middle of the fight, an argument with one of the locals, telling the truck driver something about his sister, his aunt, and his cousin, and this thing's gonna go click and lift. Just never fails. But in the same breath, at 250, 250, 250, 250, 250, and 250, there's there's $1,500 worth of transistors in this box, protected by this one little switch. So if somebody wanted to bypass that safety circuit, what they would do is they'd jump over these 2 tabs. These 2 tabs. But we'll cover that as we go on. I'm going to populate this thing. And what I mean by that is I'm going to hook up this coaxial lead. I'm going to move this over and hook it up. I'm going to make it so that the wire goes from here to here and here to there and there to here. And then I'll come back here in a minute and we'll talk about all of that and show you all of that. And then we're going to put the relay in here that actually is going to drive everything, including the bias. And then we'll run all the controls. Half the LEDs, well, more than half, exactly 2/3 of the LEDs were broken off. And this one is questionable. Like, hardcore questionable. I think I've got them sitting over here. Yeah, here's the remnants of the LEDs that were in there. Not that it really matters, but I throw those away. Don't need them anymore. As just looking at it, I've learned that this rectifier and then this rectifier were not screwed down to the heatsink at all. So I'm glad we caught that before we put a heavy load on it of any kind. But yeah, we'll replace our LEDs up here in the front. We're going to rewire in our power supply switches, this one here, and our sideband delay. We're going to do a full up switch delete on the preamp. If you got, look, you guys want a preamp, I've got the mother humper of all preamps here someplace. I thought I had it sitting right here. Let me dig around for that. I'll come back to that in the next video segment. If you're going to have a preamp, buy one externally. And my logic for that is if your preamp goes bad, you lose your receive. So now the whole box is worthless. Worthless. Yeah, it depends on how the preamp works. You know, the preamp's wired. If the preamp, just the transistor quits, well then the preamp doesn't work, but you still have receive. Some of these are built so that the preamp goes through that transistor, and if you don't have, you know, you have one wire that breaks off your preamp, the whole box is worthless. You can't hear anything through it. So I say put the preamp external and get a real preamp. Something other than a really shitty static generator, which is all about the transistor that's in here. If you had a preamp in here, that they'd mount probably right here. That's where the old one used to be. That transistor that's in there, the noise floor on its amplification cycle is such that if you turn it on, you're going to generate 15 pounds of static and only get maybe 5 or 6 pounds worth of useful signal. Or if you get a real external preamp, it's got a bunch of filters and tunable notches and all kinds of stuff so it'll allow you to get 20 S units worth of 15 S units worth of decent receive, let's say, and not a whole lot of static garbage. And if it fails, you just take it out of line and you keep on talking. That's my motto. That's why I don't bother with preamps here. It's not that I don't know how to build them. I just don't see the point. Okay, so the ass end of this thing is all rebuilt. Now we can transmit and receive and talk through it. Here, bias is all hooked back up. That's all good. This is all good. We'll come back, we'll tune this here in a minute. And we're going to move on from here because this is all done. And we're going to move on to like power wire upgrades. We'll be coming here fairly quickly. We've got to hook up our fan. That's going to be coming here pretty quick. We've got to wire our front end controls and put LEDs in place. But the next thing I'm going to do is going to fix this. I would like to ignore this, but unfortunately this is one of the things that I cannot ignore. The transformer here has broken off of its tabs, and therefore it is beating the shit out of these two connectors, beating up our rectifying diodes. It's going to probably cause a pinch point on this little orange wire, but yep. So the next thing I'm going to do is I'm going to take the transformer out, and I'm going to fabricate some new feet for this thing and make it so it's supported, so when we go to ship it home, it doesn't break off and wreck everything else that we've repaired here. Yay. Okay, transformer out, new brackets assembled, transformer back in. Also took the time while I was here to do small things like put heat shrink around the 110 power connections at the breaker. I mean, we still got solder slobber over here. We've got this whole mess to go, but we're going to thank God for small favors. The fan works now that it's wired in and not cut and disconnected. So now we have a chance to have cooling. Ass end's rebuilt. She's got a butt lift. Now we got to do a heart transplant. So now I got to tie the output of the transformer to the rectifier diodes, and we'll see what blows up from there. And I mean literally, we're going to see what blows up. Of course, I'll put it on a variac and I'll bring it up really slow. I'm not just going to hammer knife switch it and see what shit flies out of it. But you know, these things were handmade. Every one of these was handmade. I know Carl and them guys hand wound these transformers. They found the machine in the backwoods of someplace, is what they told me one time. But haven't had one with the ears bust off in a while. That's why I keep this stock around here for us. It's aluminum stock, because that's all the brackets are made out of. They're not steel, they're made of aluminum. So, anywho, we do rectifier, and we'll get our 12 volt working. Then we're going to do our controls, and then we'll do power wire. And then we'll hook it up, and we'll run it, and we'll tune it, and then we're done. Hello. Sat band delay is on. Good morning, you guys. It's super early in the morning. I went in and right down and started watching TV with my wife, and the next thing I know, it's 4:30 in the morning. Of course, I went to bed at 7:30 at night. God. Oh, the joys of working for yourself. Hello. I didn't want to see that. Oh, yuck. Well, we don't have a lot of ripple going on. AC ripple. No, sir. All right, let's perform one more test.
Okay, so this is just the radio on the workbench. And we're listening to it through a monitoring radio. Hello, 1 2 1 2 1 2.
We're good. I'll call that a win. Okay, let's now shoot this from the other perspective. Looking at the monitoring radio that's listening to the outside world. I know my noise floor here is amazing, isn't it? Took a lot of work. I had to buy a lot of stuff for my neighbors to get it this way. Garage door openers, garage door lights, all kinds of stuff. It's possible if you got the right relationship with your neighbors. So, let's go ahead and we'll turn the bench radio down here to the bowl. This is just the radio barefoot all by itself. This is what the bench radio looks like when it's out there in the atmosphere in the real world. 20 dBs over, right? Hello, 1 2. Now we're transmitting, the workbench is going into a dummy mode right now. So what we're listening to on a radio is what we call bleed, okay? It's not actually transmitted RF. There's no emitter device going on, like we're not going out to an antenna or anything. It's the RF that's leaking out of the high-end coax here on this grounded loop system, because the proximity of this radio is the reason that we can hear it. So I mean, if you went like 5 houses away, you wouldn't be able to hear the signals. So it's not like we're intentionally putting anything into the atmosphere. So once again, bass, this is just a radio, 1 2 1 2. This is the amplifier itself in operation. Hello, 1 2 1 2 1 2 1 2. And we're a full 10 kcs wide. So panel to panel, what I mean by panel is from this line here, is about 10 kcs actually on a 250 kc wide spectrum. So from here to here is 250 kcs. From here to here is a total of 20. So let's see, 20, 40, 60, 80. No, it'd be wider than that. Yeah, you guys do the math. I don't want to think about it. Hello, 1 2 1 2 1 2 1 2. But look at how overloaded the front end of the radio is, right? So we can't use this as a valid form of actual frequency occupation. A lot of people get that screwed up in their head when they're looking at waterfalls and SDRs. If you get past about 20 dBs worth of signal, you start having excess because the radio can't, the heterodyne process in the radio can't discriminate that, that much input signal. So we'll put about 18 dBs worth of attenuation on this. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. We got probably 90-95% of our outgoing power within 5 kcs, 6 kcs side to side. I mean total, not side to side, total. With 6 kcs side to side, it means it'd be 12 kcs worth of frequency occupation. So needless to say, the signal that we're putting in, i.e. the garbage from the radio, which isn't garbage, it's a very finely tuned, cleaned radio for my workbench. Thank you, Derail at Wolfman CB Shop, by the way. Amplifier's not adding a ton of shit to it. That's the whole point behind this. Sorry it took so long for me to explain this to everybody, but once again, I gotta treat every single thing as if we're being watched by a novice and not a college professor, right? Because let's face it, I'm a slightly low-functioning moron myself, so it helps me feel better if I say it out loud, I guess. Okay, let's do some power numbers here. Let's show power. So what we got here is 1,000 watt slug and peak. There's 1,000 in average. Of course, the ubiquitous 5 watt slug and reverse back from the Bird 10,000 watt dummy load. Let's play around here a little bit. Let me turn the amplifier off and let me show you radio drive. We're going to be doing all of our tests today with the Striker 955. Okay. We're on 12 volts. So please note there's going to be a huge power difference between 12 volts and when we run the thing up to 15 volts. And what I mean by the thing is the radio. So let's start here. Seeing about 80 watts. 80 watts. Oh, let's get a baseline carrier for you guys to look at too. Bump this over just a hair. Let's take the 5 watt slug, we'll turn it forward. So the relay obviously latches at half a watt. So we'll put just a hair underneath a full watt worth of carrier in it, so we're making sure that we're creating good AM. Going in the amp, we'll turn the 5 watt slug back around, and now we're going to jump back to here and to here. Okay, so 1 watt going in gets us maybe 12 watts, 10 watts, something like that. 80 watts of drive. We're getting 400 average. We're gonna have to expand our range up. We'll go to 2x over here. So now when this needle runs all the way here to the right, we're gonna find that that is 2,000 watts when we hit here. So halfway in between, because remember this is a non-linear scale. Right there's 1,000, 12, 14, 16, 18, and 2,000. Okay, so audio. Seen about 12 and some change. Maybe 12 and 1,800 watts. Let's do that one more time. Okay. From my angle where I'm standing at it, it's looking like it's going past the 12. From you guys looking straight at it, it's dead on the 12. Okay. So now let's do that entire series of tests again. Now what I'm showing you is something very simple. Okay. What we have here is a mother effer of a Striker, right? This is not your grandpa's Striker 955. This is a 1,000, depending on which version you get from him, can be $1,000 to $1,600 radio, right? Not everybody in the planet's going to have the 120, 130 watt version of this. They're not. Out of the box, straight from the crazy bastard called Sean over there at Striker, when you get these things and you modify it and make it so it works on 11 meters, everybody and their brother goes in there and they turn up that ALC knob, and then they turn the power knobs around, and they get somewhere between 90 and 100 watts. So what I'm showing you is this radio on 12.5 volts makes about 80 watts of power. Or otherwise, what everybody else is normal out of the box, not $7 million hopped up comp super friggin' eliminator, top pro mod diesel friggin' propane injected with nitrous on top radio. With 80 watts of drive going into this 6 pill, you're gonna get yourself 1,200 watts of power. Now, people that say that I mess with the voltage on video, it's not possible. I always end up bumping the camera. Let's go ahead, we're gonna turn our voltage up. We're gonna turn it up to about 15 volts. 15.0. 15.0 and floating. So we're back down on the 1x scale now. So it's reading labeled, as labeled. Full deflection over here, we're gonna add a 0 on that bottom scale. So, hello, about 110. Make sure we got all our knobs in the full and upright erectile positions. God, it's different. I say this all the time. Nobody ever believes me. See, I'm forced to stand because of the tripod I'm forced to stand at more or less this angle. Hello. From this angle, and these old beat up peepers I call my eyeballs, that looks an awful lot like 125 watts. From straight on, where you guys get to enjoy it, which would be here. Hello. About 110. And then we'll view it from the oblique angle. I can't wait to see what this looks like on camera. Hello. Right at 100 watts. Oh my God. I'm going to have to remember that. Hey man, I needed to do 10 more watts. Let's move the camera to the left. Okay. Anyhow, needless to say, same amount of baseline carrier going on. Hello. Hello. 400 watts average, which is the same as what we had on 12 volts. Let's go and turn this up to 2x. Now remember, we were farting out. We were fading into the wind at about 1200 watts before, right? Hello. Hello. Now we're getting a full 16, and remember, from my point of view, 1600 plus. Hello. Oh, wait a minute. I wonder if this will make any difference. If I unplug from the bench down there, and I plug this into a fixed 20 amp solely committed supply. See that one power strip plug there runs a bunch of shit. And it's like I can physically see the lights dimming when I modulate. God dang, dummy. I have a fixed like 20 amp or 30 amp outlet that I specifically built for the workbench. It's like way overkill, so there's no voltage drop. I'm trying to provide the most optimum situation I can. Hello. Well, that made a little bit of a difference. Hello. Hello. 1-1. Hello. It's squeaking. It's got a little bit more peak power to it, but nothing impressive. So, needless to say, this old Xforce has still got a little bit of life left in her. Old school iron transformer, real deal power supply. Yeah. I think we're done. I honestly think I'm done with this beautiful old girl. Well, gents, I got to tell you, I'm done. I'm going to call this a win. For the record, that's a 2X. Bunch of stuff happened off video that I don't even get to talk about. Hold on a sec. Hello. 1800, no problem. 1700, no problem. This is with the lid on. It is so much quieter. That little fan that's in the back is just spinning away, and as you can tell, it's obviously much quieter. One of the things that I had happen while working on this thing is my striker quit keying up. And first I thought it was the mic jack on the mic itself. So I took the whole jack apart on the mic, and everything's good there, and changed out microphones. Everything's good there. Come to find out, there's a little slip-on 4-pin like Canon plug that's on the back of the mic jack on this particular version of Striker. And for some reason it managed to just work itself off and was sitting there just barely touching. So that meant I had to take all of this shit down. this and this, and I take all this shit down to fix that one radio. I hate this, by the way, this whole setup, because this was initially designed just to hold a couple radios and have some parts. I never planned on having 1, 2, 3, 4, 5 bird meters and all these radios. And if it wasn't for this aluminum strut here, this shit would have collapsed. I hate this, so I'm seriously right now considering doing a complete bench overhaul. And the other thing I got to do out here is I got stuff stacked on top of stuff, stacked on top of stuff, stacked on top of stuff. And people are still sending me their amps, even though I've been telling everybody no now for 13, 14 months. Gotta clean, gotta organize. Well, gentlemen, I called the guy to tell him what we had going on, and he says, well, you know, BBI, I bought that amp for me to send to you, and you were gonna rebuild it, and we're gonna sell it. And I was like, oh, man. I know you guys are getting tired of the for sale videos. I'm getting tired of it, too. I'd love to just pick one up and be like, hey, look, I'm fixing this for Bob, or I'm fixing this for Kevin. Well, Mr. C, I don't want to say you slam dunked it on me because, well, you didn't. But here we stand. We were talking on the phone, and I was like, dude, the transistor market is a mess. He goes, what do you mean by that? And I said, well, by all accounts, and this is real world, each one of the transistors in here, because they're legit Toshibas, are like $200 and some a piece. So there's anywhere from $1,200 to $1,500 worth of transistors in this cabinet. Well, this is what it is, a used Xforce amplifier that's been completely reworked on the inside, and there's nothing wrong with it. It's just, it's not like a new build, right? And I said, well, dude, in the real world, you know, we'd ask like $2,600 for it, because we know how much the transformer costs, the cabinet, the heat sink, the board, the transformers, the wire, the partridge in a pear tree. But that's new. This is used. And I said, ain't nobody gonna pay for that, because nobody's interested in the Toshibas, it seems like, anymore. To me, I would take the 30-year-old component over the Chinesium, but the Chinesium is taking over the market. So now the Toshiba transistor value is starting to go down a little bit. I told him, I said, you know, we could probably ask 19, but ain't nobody going to pay that neither. I said, you know, a fair, honest asking price for this, in my opinion, and I'm going to leave it up to you guys a little bit, just a little bit. If somebody calls me up and offers me somewhere between $1,500 and $1,400, this thing can go away. It's going to go have a new home, go enjoy life. Things are good. Things will be good. So the first person to call me, text me, whatever, what have you, gets it. So $1,500 to $1,400 plus the ride. Now listen, this is an old school transformer unit. It isn't the new Featherlight built with LED switch modules in it. Okay, this has got a transformer in it. So that means no cardboard box. We're gonna have to put it in a little bit of a wood crate. You're gonna have to plan on spending a little bit of money on shipping. But if it's me personally, if I was to go build myself a base unit today and use this style of technology and not LD Moss, yeah, bet your booty that it'd have a transformer in it. Just saying, that's just me. Especially taking into account how hard it is to get the damn switch modules anymore. Although I got a whole shelf of them over here. That's because they're here for repair. So on that note, I want to say thank you to all the Patreons that kind of help keep the lights on over here, and they show me a little bit of love and support. Well, thank you guys. Big shout out to Siglet, Excess Power, MechMan, Bird, and Coaxial Dynamics. God bless Gray Label Xforce. God bless you guys. On that note, I want to say thanks, gentlemen. Appreciate everybody tuning in. This was not planned to be a for sale video, but it is what it is. On that note, I say thank you, and we'll see you on to the next one. Click, click.